Hello everyone, I'm Han Song, and I'm going to explain the second question in the homework 2. So let's begin the first question. Draw fx equals 1 minus e to minus alpha x times mu of x minus c, and what we need to do is to verify that, to show that whether fx is valid probability distribution function. So let's begin. First, let's let mu ux equals 1 when x equals 0. So since u of x minus c is unit step function, so when x is less than c, so u of x minus c equals 0. So when x equals c, fx will equals 1 minus e to minus alpha c, and since alpha and c are positive constants, so e to the minus alpha c is larger than 0. So fx is less than 1 when x equals c. And on the other hand, as c grows up into infinity, e to minus alpha c will become 0. So fx will become 1. So we have know that when x equals c, fx will less than 1, and when e to minus alpha c becomes 0, when c grows up into infinity, fx will become 1. So the graph for the fx will be like this. This is c, and when x equals c, this is the value for fx will get. And when the x grows up into infinity, it will become the fx will become 1. And according to this graph, we know that f of minus 0 equals f of minus infinity equals 0, and f of infinity equals 1, and the function is non-decreasing, just as this. So we can know that fx is a probability distribution function. And the second question is that find and draw fx, which is the derivative of fx, and verify that fx is a valid probability density function. So let's begin. Fx, as in the title have shown, fx equals dfx over dx, and after derivate fx, we get this equation, and since hx times delta of x minus alpha equals h of a times delta of x minus a, so fc will equal to alpha times e to minus alpha c times mu of 0 plus 1 minus e to minus alpha c times delta 0. And according to the probability of delta x, the probability of delta x is delta 0 equals infinity, and and integrate delta x from minus infinity to infinity equals 1. So when x equals to c, the area defined by fx is 1 minus e to minus alpha c times this one, and because this one equals 1, so we can get that this one equals 1 minus e to minus alpha c, and when x is larger than c, fx equals to this one. So we now can sketch the graph for fx is just like this. When x equals c, the area defined in c is 1 minus e to minus alpha c, and when c grows up, the graph is like this. In order to prove if it is a probability density function, we can integrate from minus infinity to infinity of fx. We can split the integration into 3 parts. This is the first part from minus infinity to c, and the second part is the area, and defined on c, and that's the last part, the integration from c to infinity, and after calculation we get the result 1. So we can get the conclusion that fx is a probability density function.